Good afternoon, students. How are you doing today?
Afternoon, sir.
How are you?
How are you, sir?
Say that again, Mikey.
Not too bad, sir.
Afternoon,
Okay. Good afternoon. Hey, doctor. What you do? Says
sir.
just look.
Not too bad, sir. And you?
I'm giving thanks. Could have been worse. Um, so how are the rest of you? Joanna, Tariq, Kazay, Courage, Tony, Ashantia.
Okay, sir.
Okay.
Good afternoon, sir. Not doing bad so far.
Okay. All right. So what I did just now was to give you three little quick refreshers. I'm gonna ask that you. By the way, has anyone completed all those three? Yeah. No. Are you working
Sir,
on
can
them?
you repeat for me, please?
Working on them, sir.
Okay. All right. So okay. All right. No problem.
Sir,
Should I
which
give you a couple
three
of them?
questions?
Say it again.
The questions. I didn't hear what you said about the questions.
Oh, you're not seeing it being projected?
No. Oh, they say, mine is still blocking. I
I don't hear you. Say it
can't share.
again.
I'm going to go on my laptop now. Hopefully, I can see them. Don't see them as yet. I'm on my phone now.
Oh, okay. Everybody has seen the question?
Yes, sir.
Okay. All right. Good. Thanks.
Sir, I'm not saying yes, sir.
Say it again.
Not sir.
Oh, you're not seeing the question? Daniel, what were you saying to me just now?
Sir, I'm not
I am
saying
not
sure.
seeing the question.
You're not seeing the question? Or are you seeing them now?
Yes, sir.
Yes, sir.
Okay. Okay. All right. Go ahead. All right. I'll give you a few. How are you with that question? Are you in agreement with me for question number 3? Sorry, question number 2? Hello? Somebody? Anybody?
So just reach it and then work it.
Work it for me, please. I'm changing position. Hello? Are you hearing me, students?
Yes, sir.
All right, good. All right. So have you completed are you in agreement with question number 2? Or is it that you don't remember? What does that mean?
Still working on it, sir.
Still working on it, Mikey? No, man.
Sir.
All right. All right. So let me just ask you to press
Slowly I
pause.
come back to my brain. So.
Slowly coming back to you. All right. Let me just pause and do some housekeeping. Welcome to Calculus 2. I am going to encourage you all to go to your Arion, look to see um, your grade. The prerequisite for Calculus 2 is Calculus 1. The prerequisite for Calculus 2 is Calculus 1. Um, so I'm going to ask that you pay close attention to that, and then I'm going to congratulate those of you who made it over to Calculus 2. Calculus 2 is going to be building on the premise that you remember how to differentiate, you remember how to integrate, because what we are going to be looking at are the applications to both integration and differentiation. So those are very critical. So in addition to those, there are 4 students, 1, 2, 3, 4 students, 5. So there are 5 students that I would expect. Well, 2 new faces that I'm expecting. I sent a message, but I
Sir.
don't see a response yet. Go ahead, please.
I just came in, sir, because my Wi-Fi was giving problem, and it said Marction has started sharing screen for the past 5 minutes.
No, I've been sharing screen no longer than that, sir. I gave work already. I gave 3 questions for you to do in class. Those are the 3 questions. Can you see them?
No, sir.
Can anybody else see the screen? Am I still sharing?
Yes, sir. Yes, sir.
Yes, sir.
All right. That's what it says. It says I'm sharing. So come on, you need to go and check your
I'll
connection.
return, sir.
Yeah, man. All right. So for those of you who are here and shouldn't be, you can stay for tonight. I need your company for tonight, but come tomorrow, we need to regularize our class setting. Just confirming based on what it is that we obtained last semester. We met on a Tuesday, 5 to 7, and last semester we met on a Thursday, 7 to 9. Well, 7 to 10. It should be a longer semester this semester, so I think we should be able to keep the 7 to 9, but the class has moved from a Thursday to a Wednesday. Do you all have that same change on your timetable?
Yes,
Yes.
sir.
Yes,
All
sir.
right. So we'll be meeting today and tomorrow. Very good. Um, so right out the bat, I need to speak about the participation in the session. And this is a carried forward discussion from last semester that I am not going to be competing with getting students to respond to me in class. Matter of fact, coming out of a meeting today, it was a center of discussion about students' participation in their lectures. So many times tonight, this evening, I've been asking, are you hearing me? Are you hearing me? Because I'm not hearing the response. So when I ask if you're hearing me and I'm not hearing anything, I will just go silent because I'm not going to be in it this semester. I'm really serious about it. We mean business, and all I'm asking you to do is just to stay alert. What I recognize is that some of you are logged into class, but some of you are not there. You are logged in, but you are not there. And when I call upon you, you're not responding. because you're multitasking. That is unacceptable. And, we really need to brush up on that for this semester. Now, let me jump to the other level of conversation. When you look at your grades, any student that falls within a band C minus to a C plus, I'm going to be requiring much more out of you, because it means that your work in Calculus 1 was satisfactory, but there's still room for improvement. I am going to be assuming that you know how to differentiate, and I'm going to also assume that you know how to integrate. This class is not to teach you to integrate, neither am I to teach you how to differentiate. What it is that we're going to be looking at are the applications to differentiation and integration. So which is why I give you these 3 questions, just to refresh your memory. It's day 1. I'm not going to be teaching those stuff. So for those of you who are struggling, my YouTube channel is still up and going. Please to familiarize yourself with Calculus 1. For those of you who want to move ahead, I also have about 3 or maybe 4 series of Calculus 2 embedded there. If you so desire, you can go ahead with those past lessons and work ahead of me. Don't wait on me, work ahead of me. In addition to that, you also have your EducaSoft that I'm going to ask that as soon as it is set up, that you get going. One of the things that I'm going to be doing differently this semester is the struggles that I had with you in completing your pieces of work. I'm positive that I won't have it this semester because I'm going to be closing out the assessments in a timely manner, because it's just unacceptable. We are bachelor students, and I'm expecting more of you. Are there any questions that you have of me? No?
Sir, the exam online or face to face?
I guess your exam will be face to face like it was in the first semester.
Okay.
So what is going to happen now is we can't just barely understand, because when you go, you're not going to have, for the online exam, you'll have access to your stuff. You'll have access to your stuff. You For the face-to-face exam, you won't have that available to you. So you have to be more intentional for your exam setting. You have to be more intentional. Any other questions? All right, so let me just remind you.
Uh,
Go ahead.
well, sir, it doesn't matter because you're gonna start with it eventually. I was just asking about the EducaSoft.
Oh yeah, man. I have not yet given. What I'm going to be doing is promoting students from the grade sheet that I have up to Calculus 2. So which is going to just remind you all about the prerequisite for the course. Let me just say, Mrs. Campbell and I had a conversation Sunday night, and the discussion is for those students who did not get through with Calculus 1, that we're going to be having a fast track in Calculus 1 on the weekend to give students an opportunity to redo that course in this semester. Now, if you fall into that category, I'm going to ask that you so speak to Mrs. Campbell to get going. If you don't do that, we are going to be running a fast track of Calculus 2 in the summer, and I can't guarantee you that there's going to be a fast track in Calculus 1. So the opportunity now arise for the Calculus 1 to be offered for this semester. I would encourage you to make good of the fast track. So at least in the summer semester, you'll be able to participate in the Calculus 2. So those of you who are year 3 students, you don't have to carry over any of the math courses into year 4. And those of you who are year 4 students can at least know that you complete your Calculus 1 and 2 en route to completing your bachelor's. All right. Any other questions? And we need to go. Have you completed the other questions I was asking? Are you in agreement with the answer that I got for number 2?
Sir, when we read it out, it seemed right.
When you read it out, what do you mean?
I slowly I try get back my groove in the whole calculus thing. So the one that you have, or the answer that you have, it kind of refresh me on the steps or the procedures.
Okay. Does anyone remember how it is that we do? But by the way, number 2 is which one? What method do you use for number 2?
Quotient rule.
The quotient rule,
Quotient
sir.
rule. And what does the quotient rule say again?
The denominator times
Numerator times the differentiation of the numerator minus the
numerator
numerator.
times the differentiation of the denominator.
All over the denominator.
Denominator square.
All right, good. So the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. All right. So the denominator is x minus 1 all square. So it's going to be the denominator, which is this x minus 1 all square, times the differentiation of the numerator. When I differentiate the numerator, x plus 1, the differential of a constant, remember, is equal to 0. And the differential of x is going to be 1. So that's why I have this times 1. It's not 0.1. For those of you who are joining for the first time, it's not 0.1. That dot means multiplication. And then minus the numerator, so it's going to be minus x plus 1 times the differentiation of the denominator. When I differentiate x minus 1 all square, I'm going to get 2 times x minus 1, reduce it by the power, and then I'm going to differentiate what is on the inside of the parentheses. And the differentiation of x minus 1 is?
X minus 1 is 1.
Is 1, right? So there's a times 1 outside here. All over the denominator square, which is x minus 1 square, all square. And recall, a to the m raised to the nth power is going to be a to the m times n. So those 2's will be multiplied together. So it's going to be 2 times 2 is 4. So my denominator now becomes x minus 1 to the 4th power. And then I'm going to be having this as my numerator, x minus 1 all square, minus 2 times, all I'm doing is just putting the 2 in front. So it's going to be 2 times x plus 1 times x minus 1. All right? And then I recognize that x minus 1 is common to both sides of the negative sign in the numerator. So I'm going to factor out the x minus 1. Remember, we factor out, is it the larger or the smaller of the 2? What do we do? Which of them we factor out? The larger of the 2 or the smaller of the 2? Remember, we factor out the smaller of the 2. Right. So that's why I'm taking out just the x minus 1 and not the x minus 1 all squared. So we're taking out the smaller of the 2. All right. Remember, we are factorizing. When we're factorizing, we're taking the smaller of the 2. All right. So I'm taking out the common term is x minus 1. X minus 1. So I'm taking the small of the two, so it's going to be x minus 1 to the first power. I don't have to write the first power. So it's just going to be x minus 1. Then what is going to be left? I'm taking out one of the x minus 1 from this x minus 1 all squared, which is here. And then I'm taking out the x minus 1 from the second term. When I say second term, remember 2 times x plus 1 times x minus 1 is one term. All right? So what is going to be left is going to be 2 times x plus 1. And of course, all of that is going to be now over the x minus 1 to the fourth power. What I'm going to be doing is to cancel this x minus 1 into one of them in the denominator, into one of them from the denominator. All right? And it's going to be x minus 1 to the third power. And I'm canceling this x minus 1 from the numerator. So what I'm going to have is x minus 1 minus 2 times x plus 1 all over x minus 1 raised to the third power. And then I'm doing my expansion. So this, I'm removing my parentheses from the x minus 1, so it's going to be x minus 1. And then this negative 2 times x is negative 2x, which is right here. And this negative 2 times 1 is negative 2, all over my x minus 1 to the third power. X minus 2x is negative x, which is right here. And the minus 1 and minus 2 is minus 3, which is right here. Still over x minus 1 to the third power. Okay?
Over,
Sir, you can run back that last part, sir. The one at the end.
Mikey?
Yes, sir.
This line here, or this, no, this line here.
Yes, sir, that one.
X minus 2x is negative x, which is here. And negative 1 minus 2 is negative 3, which is here. Remember, when I'm adding and the signs are the same, I add the numbers and put back the sign. So I'm adding negative 1 to negative 2. Adding those two numbers, the signs are the same, so I'm going to add 1 to 2 to give me 3. And then I'm going to put back the sign. The sign is negative, so it's going to be negative 3. When I'm adding and the signs are different, I'm going to subtract. So when I have 1x from 2x, so I'm going to, but I'm going to put back the sign of the bigger number. The sign of the bigger number is negative 2x. So it's going to be a negative x. So that's why I end up with my negative 3 minus x. Now, if you had written negative x minus 3 over x minus 1 to the third power, you'll still be given full marks for the question. You'll still be given full marks. All right? Any other questions?
No, sir.
Have you done question 3?
No, sir, not as it.
All right, let me give you a few minutes for question 3, and then I'm going to hit the ball on the ground running it. All right, so I'll give you a few minutes. I'm going to mute. Has anyone completed question number 3?
Yes, sir. I've completed it and sent it in the chat.
Oh, you completed it and sent it in the chat. Sorry. I need to double check. Are you the only one, Tariq? Anybody else has completed it?
Yes, sir. I'm the only
Yes,
one
sir.
before.
Okay, courage. Okay, you're all right. Post yours in the chat also, courage, so we can compare those answers, please. And the rest of you, please. The semester just ended 2-3 weeks ago, so you can't forget how to do these differentiation. All right. I'm gonna work the question.
Sir.
Hello?
Sir, you hear me?
I'm hearing you, sir.
All right. So Jones is in your class.
Yeah, I sent you a message, but you have not responded to me.
Yes, sir. I'm responding.
Hold on. Okay. Sorry. Okay, I'm just trying to catch up.
Sure, no, sir. I can't talk. No, sir.
Sorry, let me just respond to this one. All right, go ahead. Is it Bijan?
Yes, sir.
Okay, go ahead, sir.
All right, so we do calculus 1 a good while. We only have calculus 2 and past time management to basically complete the degree. So it's not so fresh in my brain. So when I beat everybody, just consider.
No, you see, wait.
Yeah, well, so what me I go do, sir? Me go try for tonight. I'll try my calculus 1 book and try go through. So
right, you have
like everybody else one.
And what you can do is when I set up the WhatsApp group, matter of fact, the WhatsApp group is already there. I don't think I deleted it. You can just put your information down and you should be added to the WhatsApp, and then you can access my YouTube channel, so you can get the information from the previous calculus 1 classes to be afresh, keep afresh as to what is.
I can send my number in the chat.
You can send a number in the chat. Somebody will add it to the group for me. All right. So, but we'll have further conversations as it relates to that, I'm sure.
Right,
I'm gonna do the question on screen. I'm gonna do the question on screen on the listener, but I just want people to just get back into the groove of school. I know this is the first class for the semester, so just that. All right. I'm
pick up box, sir.
Yeah, man.
Pick up box, sir. All right, sir.
All right. Bless up. Take care. All right. I'll give you another couple of minutes, guys, to just complete the question for me, please. Thanks.
Sir?
Yes, Mikey?
No, it's not Mike, it's Tariq.
Yes, sir.
I was just wondering what's going on because the
No, I'm
place
waiting on the
was get
others.
quiet.
You
Mm.
you have said that you have I'm seeing your stuff, I'm seeing Courage's stuff, but I'm not seeing anybody else's stuff. So
Mm.
I need to hear from the other students. You remember Sir saying, "No, this is a new semester, and if you don't talk, you're not going to talk." So
Sir,
I'm
But
waiting.
sir,
remember
sir,
Jones just tell us say.
No man,
sir,
Jones, you're out of it, Jones.
All right,
We hear your
beautiful.
story, Jones. But what
sir,
about Crossdale? What about you, Crossy?
Sir, I'm stuck.
we don't want you to talk because them not
Stuck.
brave to talk. We can't go
I
through that
don't
right
care.
now.
No,
This is the
start the
stage where,
talking.
sir, we can't force nobody, everybody are adult, sir. As you said,
But guess what? No, but guess what? You see the thing about it? I hear you, Tariq. I was in a meeting today. You know what? Because of the poor performance, you know what? It has caused me and my team now to go and do? To go and do research to find out why is it that the students fail the course. Me already know me go right on. I am come to
mm,
class and I'm talking to students and students not responding. Straight up.
sir,
Straight up.
sir, them
No,
know what them are doing, sir. And unlike children where you can always make up an. And say your child is shy. Them know what them
Tariq,
are do. Everybody
I
here for a purpose.
I
And
hear you, Tariq.
sir, today
I
to share is
Debating.
all right,
I
so you
hear
hear me. So make a finish. That's
no
true.
man, I hear you, Papa. And I'm right where you are, Tariq. I'm right up that stream. But you see, I'm watching though. There are other students in the class. I mean, you and Courage sent the stuff in the chat. I am waiting. Bijan spoke to me about him doing that.
So you know some me stuck.
No, but Lotto, you stopped me one. You said to me, "Sir, me stuck."
Wait,
Okay,
may I give other people them a chance.
um, utterly, I responded to you, but I just recognized utterly that the thing not going to a click. Yes, but I don't know why it's not moving. All right, let me come out and
I'm stuck to sir. That's why I want you move on, to be honest.
you, you stuck?
Yeah, we stuck
Sir,
to come. Send
let
the
me know,
answer.
sir.
I
I'm
believe
stuck.
say have
I
doubt.
used to say look like you're wrong, Tyree.
Yeah, my one must
I'm
strong.
sure if you correct you wrong.
Oh, okay, I hear you now. But now going well enough because you see this calculus 2 is integration and differentiation application. So one of the application questions to differentiation is um is stationary points. We have done stationary points from calculus 1. I will not be doing that stationary point again for calculus 2. Single variable function, that is. I'm going to be now moving into the multivariable functions. So don't believe that what it is that
What was that in exam, sir?
I was not in the exam.
Yeah.
Nobody got 20 out of 20. The closest was 19 out of 20.
Mark, you know.
No, but I can't tell you, nobody got 20 out of 20. The closest was 19 out of 20. Then about two or so, maybe three students got 16 out of 20. One student got 15 out of 20. And then maybe you had two or three others getting between 10 and 14. And then everything else was cash free money. And I mean, I just sat down and just shake my head and said, I can't believe that I sat down one whole semester and telling her, said, this is a staple on the table that it must come, and Una still never do the something. That is my level of frustration. I said to you, it is coming, and most of the students in the class, there was about 6 or 7 students who got um, 14 and above on the question. One student got 19. Nobody got 20 out of 20. So I don't know. But anyhow, I'm giving you 2 more minutes and then I'm going to work the question on screen. 2 more minutes and then I'm going to work the question on screen.
Sir, can you please stop sharing and share back? I've rejoined many times and I can still see your screen.
Oh, can you see it now?
Yes, thank you.
All right, okay, no problem. Let me just mute and then go back. All right.
Sure, some answer in the chat.
All right, so can you see the screen and hear me at the same time?
Yes, sir.
All right, so
Yes, sir.
it's a product. So y is equal to 2x plus 5 all squared times 3x minus 1 all squared. The product rule says the first times the differentiation of the second plus the second times the differentiation of the first. But with this question, you recognize that you're going to be contending with the power rule for both terms in the question. So dy by dx is going to be equal to the first times the differentiation of the second, 2 times 3x minus 1 to the first power times the differential of the inside, which is 3, plus the second, which is 3x minus 1 all squared, times the differentiation of the first, times 2 times 2x plus 5 to the first, times the differential of what is on the inside, which is 2. Do you agree with what I have there? The first, 2x plus 5 all squared, times the differentiation of the second. So I'm calling this one the first, and I'm calling this one the second. So it's the first times the differentiation of the second. When I differentiate 3x minus 1 to the second power, it's going to be 2. This 2 comes in front, which is here. And then I'm going to write back my 3x minus 1, reduce it by 1. But because it's a power rule, I must also differentiate what is inside the parentheses. And the differentiation of 3x minus 1 is going to be 3, which explains this 3 right here. Plus the second, remember this is the second term, 3x minus 1 all squared. So this is my second term, times the differentiation of the first. When I differentiate the first, it's going to be 2 in front of my 2x plus 5. See it right here. I'm reducing it by 1, and then I'm multiplying by the differentiation of the inside of the parentheses. And the differentiation of 2x plus 5 is 2. Are you with me with that so far?
Yes, sir. Right
Yes,
there.
sir.
All right, good. So now what we have is, oopsie daisy. I want to read. What I now have is dy by dx is going to be equal to 3 times 2 is 6 times 2x plus 5 to the second power times 3x minus 1 to the first power plus 2 times 2 is 4 times 3x minus 1 to the second power times 2x plus 5 to the first power. What is common to the left and right of the positive sign? What terms? All right, so 2 is common
X
between,
plus 5.
right, but 2 is also common between 4 and 6, right?
Yeah.
Agreed?
Yes, sir.
And how many of the 2x plus 5 can I take out?
1.
1, very good. Remember, the lower of the 2. And am I able to take out anything of the 3x minus 1?
Yeah, 1, 2.
And can also take out one of the 3x minus 1. 3x minus 1. Now, my question to you, what is left?
I want to go left now.
3,
3, good. What else?
2, in bracket 2x plus 5.
I agree. Sorry. Hold on, I have one challenge.
Okay, can you hear me? Check it and finish it. What is it? Me fair presenter?
Mute for me, Mikey. Yeah. Are you guys still seeing my screen?
Yes, sir.
All right, I'm just trying to. All right, I'm unable to. Three times 2x minus 5. Sorry, 2x plus 5. And what else is left? Plus 2 times 3x minus 1. Do you agree?
Hold up there, sir. Hold on there. So, let me know how you get that 3D again, sir.
What is common between 2 and 6?
Okay.
Remember, we're factorizing?
Yeah, all right.
Right. So, and again, I'm going to say the same question, ask the same question. What is
Yeah,
common
so
between 2 and
2.
4? So that
Yeah,
we have
me
two
understand
there.
now. Yeah.
All right. Okay, so far, any other questions? I don't want, when I finish it, it says, sir, can I go over, just look at the stuff and let me know how far, if it is that you're following, what it is that is happening.
Sir, you said a 2, and in the last line is what is common between the 6 and the 4?
The 2, which 2 are you talking about? This 2 right here? Where my
No, sir, the one at the front. The front
this
one.
one here?
Yes,
right.
sir.
What is common between? What is common between the 4 and the 6?
Okay, sir.
Right. So the factor that is common between 4 and 6 will be 2. So I'm factoring out my 2 because remember what we're doing there is factorizing.
So when we to see,
Mhm.
when you have the power of 1, you can't always write it. You have to write it.
You don't have to write it.
Oh, okay. Just
Yeah,
for exam
because
purpose, you want to see it.
No, you don't have to write it. I'm putting it there because I recognize people don't remember how to differentiate. So I'm showing them what is happening. But you don't have to write.
All right, so.
Anything raised to the power of 1, it's that same thing. So you don't have to write it. Once it is greater than 1, you must write it. Or if less than 1, you write it, yeah.
All right, sir.
Okay, so far?
Yes, sir.
All right. Now, what I'm going to be doing in my square parentheses, I'm going to be expanding. I'm going to be expanding my terms. I'm going to be expanding my terms, all right? So what I'm going to have, let me just change this here. What I'm going to have is 3 times 2 is going to give me 6x. And 3 times 5 is 15. And 2 times 3 is 6. And 2 times -1 is -2. And of course, I'm still going to have my 2 into 2x plus 5 into 3x minus 1. And so all I'm doing is just expanding. 3 times 2x is 6x, and 3 times 5 is 15. 2 times 3x is 6x, and 2 times -1 is -2. It's -2. And what is 6x plus 6x?
12x.
12x. And what is 15 minus 2?
13.
Very good. So this is 12x plus 13. 12x plus 13. And of course, this is going to be my 2 times 2x plus 5 times 3x minus 1. And that's what dy by dx is equals to. I'll take your questions now. Matter of fact, did anybody get that? Courage, did you get that? Carrie, did you get that?
Nope.
No, sir. Far off.
Actually, so before I got the last part, I didn't really remove the 2. I got 24x plus 26.
Oh, so you got the 2x plus 5 times 3x minus 1 times 24x plus 26.
Yeah.
All right, so I made us penalize it with a little 1 mark right there. Very good, though. Very good. So this is our quick refresher. This is our very quick refresher on what is expected of us. Let me hear how you feel. Bijan, how you feel?
So, you know, to me kind of like calculus. It's just that maybe out tight for a while, so me go do that. Go.
You know that thing.
I get back in that group. No worry yourself, son. I get back in that group.
Nice. Any other comments from anybody else?
So my thing is the factorization. Right there.
Okay. So you remember the
line
rule?
3 or yeah, man, I did the rules and the thing is to factorize. That would be line 4. 1,
Right.
2, 3, 4.
Yeah, line 4. Right here when you're factoring out the stuff. So just remember, it's the lower of the 2 that you're taking out. Just remember the lower of the 2 that you're taking out. And you just look. So a question such as this, you will have both terms involved. And you're taking out the lower of the 2.
Sir? All right, so for the line with the brackets, sir, we have the 3 as a power in front of the bracket. I don't understand how you got that.
Line 4.
All right.
Factorizing
So that's exactly what Lotte is asking. We're factorizing. So this line here, are you seeing my spotlight?
Yes, sir.
Okay. So 6 times 2x plus 5 all squared times 3x minus 1 plus 4 times 3x minus 1 all squared times 2x plus 5. You're looking to see what is common to the left of the positive sign and what is common to the right of the positive sign. Now, what it is that I did was to look at my whole numbers first. I recognize I have a 6 and I recognize I have a 4. So 6 and my 4. Now, what is common between 6 and 4? It's going to be 2.
That's 2.
That's 2.
So I take out the 2. So that explains this 2 right here.
Yes, sir.
Got me? Good.
Yes, sir. Got that.
Now, let me color code something here for you. So This term in green corresponds to this term here in green. And then in orange, this term corresponds to this term. So I'm looking at the terms now to see which is which. So I'm going to look at the terms in green. And I recognize on one side I have 2x plus 5 to the second power, and then 2x plus 5 to the first power. Now teacher says from
Small
calculus 1
from
to
the
take out
big.
the smaller of the
Smallest.
two. Yeah, man. So I'm going to take out 2x plus 5. So this explains this 2x plus 5. Let me spotlight again. That explains this 2x plus 5 to the first power. So Bijan, that's why I wrote 2x plus 5 to the first power, because I want to show you that's the one that I'm taking out, the smaller of the two. Always, every single time, the smaller of the two. And in with a similar argument, I'm going to be doing the same thing with the ones highlighted in orange. 3x minus 1 to the first, 3x minus 1 to the second. I cannot factor out the 3x minus 1 to the second because that is the bigger
Bigger.
of the two. Right. It's the smaller of the two that I'm interested in. Once you're factorizing, the word factorize means that you're taking out what is common between and among terms. If I take out the 2x plus, if I take out the 3x minus 2 all squared, sorry, 3x minus 1 all squared, it means that I'm not factorizing because 3x minus 1 all squared is not common to both. It is just, it is only in one. All right. However, 3x minus 1 to the first power is common to both of them. So that's why I'm taking out that one. It's very important that you follow that. All right. So when I take out the 2x, the 3x minus 1 times the 2x plus 5, I'm going to be left with now what is common, what is left. Now I need to find out what is left. What do I multiply by 2 to give me 6?
Oh. 3.
And that's why I have a 3 right here, because that's what is going to be left. All right. What do I multiply by?
So I'm not hearing you.
You're not the only one. Seem as if my Wi-Fi is drop off.
Talk to me now. What is left?
So we weren't doing anything. I will not see your screen.
Yeah, I think I just got disconnected a while ago. Are you hear me?
Yes, we're hearing you, sir, but not seeing.
Yeah. Hold on. Does that happen? Are you hearing me now?
Yes, sir, we're hearing you.
Yes, sir.
All right. So every time I share screen, I have to also play audio share. Okay. All right. Hold on a minute, please. All right. Oh no. All right. So I'm still sharing, right? Still seeing the screen?
Yes, sir.
Yes, sir. We're seeing it
All right.
now.
Good. 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 Now, so what I'm saying to you is, you know, this thing look like it won't. I'm gonna play with it. You know? It is at 13. All right. So what I'm saying to you now is, what do I multiply by? Sorry, 2x plus 5 to the first power. How many times can that go into 2x plus 5 to the second power? It can go in there one more time. So that's why I have 2x plus 5 by itself. So these two terms, 2x plus 5, when multiplied by 2x plus 5, I'll end up with my 2x plus 5 all square. All right? And then now, how many times, what do I multiply by 3x minus 1 to give me 3x minus 1? What number is that?
I understand that question.
What do I multiply by 2 to give me 2?
2 ones, 2.
1, sir. 1.
1. Yeah, 1. So that's why this is going to be 1 right here. So if I
So I'm
want,
not
I
seeing
put
the
2
cursor.
times 1. So I just move it right here. Are you seeing it now?
Okay. Yes, sir.
All right, good. And then now, in a similar manner, what do I multiply by 2 to give me 4? Is this 2?
It's 2 square.
What do I multiply by 3x minus 1 to give me 3x minus 1 square? It has to be a 3x minus 1. And what do I multiply by 2x plus 5 to give me back a 2x plus 5 is a times 1. So it cancels out right there. All right. So now what is left for me to do is just to fix up what is inside the parentheses here, because these outside here cannot fix up any further now. These are in its simplified form. So I'm just fixing up here now by doing my expansion. 3 times 2x is going to give me 6x. 3 times 5 is going to give me 15. 2 times 3x is going to give me 6x. And 2 times -1 is -2. And then I'm grouping my like terms. 6x plus 6x is going to be equal to 12x. And 15 minus 2 is going to give me 13. So that's it.
Okay, sir.
So when you look at all of this here, it's just factorization. So when you look at that and this, I'm factorizing in order to get my final answer. That's all we're doing right there. That's all that we're doing right there. Okay, so far?
Yes, sir.
Yes, sir.
All right. All right. So all right. Hold on for me. All right. So what I came planned for tonight, I won't be able to do it. But what I would want to do is I want to see if I can just share.
So you could send it and attempt it.
Yeah, man. Yeah. That's always a plan. I'm gonna just project something and just use maybe about 5 minutes to just talk to you about it. So let me just share Microsoft Edge. Sorry, I recognize something with the system now that whenever I share my screen, it automatically mutes the call. So do me a favor.
Sir.
Go ahead, Bijan.
Sir, sorry about that. Me have to leave here.
All right, no problem, Papa. All right. So I want you guys to do me a favor. Whenever I share my screen, and after sharing the screen, you're not hearing me, just tell me, sir, we're not hearing you. Because I recognize once I start sharing, it automatically mutes the stuff, and then I'll have to share my audio. So let's go. I'm sharing my screen. So this is the or single variable function that we did last time around. Whether or not it was well done, I won't be going through this, not even as a one example. You're gonna go and review your stuff. One of the things that I want to do with you tonight, I'm looking for some rules that I typed up for you, but I just can't find it. Okay, there you go. All right, so I have those rules for you. All right, so let me just run through one quick question, then I'm going to send this off to you, and along with my rules. Um, hold on. Hold on, I just stopped sharing a while ago. All right, so we have 5 minutes. So let me just go through and show you what is happening here. So the question says to find the horizontal and vertical asymptotes. We're looking at the horizontal and vertical asymptotes. Now,
So,
yes, not hearing me?
yeah, it's okay now.
Okay. Yeah, just give me 2 more minutes. So to do the horizontal and vertical asymptote, what we're going to be looking at for the vertical asymptote, we're going to be looking at the denominator. For the vertical asymptote, we're going to be looking at the denominator. So I'm going to set the denominator equals to 0. And I want you to always remember that. I'm going to set the denominator equals to 0. I'm setting the denominator equals to 0. So when I set the denominator equals 0, it's going to be x minus 1 equals 0. Then I'm trying to find the value of x. So I'm going to be undoing I'm trying to find the value of x, so I'm going to be undoing. So it means then, since I have x minus 1 all squares equals 0, to undo it, to get rid of that square, I'll have to find the square root. To get rid of the square, I must find the square root. I must find the square root. To get rid of the square, I must find the square root. And in finding the square root, what it is that I'm going to be doing thereafter is to say the square root of x minus 1 all squared is equal to the square root of 0. And magically, once I find the square root of both sides, all I'm going to be left with is x minus 1 equals 0. All I'm going to be left with is x minus 1 equals 0. And when I have my x minus 1 equals 0, to find the value of x, I just add 1 to both sides. I add 1 to both sides. And when I add 1 to both sides, x is going to be equals to 1. So my vertical asymptote occurs when x equals 1. My vertical asymptote occurs when x equals 1. Nothing hard about it. Nothing too difficult about it. All that I'm doing is just, the only thing that is difficult about it is to know which of them you're going to be setting equals to 0. Once you're finding the vertical asymptote, it's going to be the denominator that you put to equal 0. The vertical asymptote, you're going to put the denominator to be equal to 0. The denominator is what is going to be equal to 0 for the vertical asymptote. For the horizontal asymptote, you're going to make the numerator equal 0. So the worst thing that you need to do, worst case scenario, is to know which is what you're going to put to equal 0. So for the vertical, it's the denominator. For the horizontal, it's going to be the numerator. So if you're going to put the numerator to be equal to 0, what is the value of x for the numerator? What will be the value of x for the numerator?
Sir, not hearing you, sir.
Now, what I'm saying to you is if you put the numerator, are you hearing me now?
Yes, sir.
Yes, sir.
So I'm saying if you, for the vertical asymptote, for the horizontal asymptote, you're putting the denominator to be equal to 0. You're putting the denominator to be equal to 0. So, not the denominator, the numerator to be equal to 0. For the horizontal asymptote, the numerator is equal to 0. What I'm saying to you is, when you set the numerator to be equal to 0, what do you get for the value? Look at the question. X over x minus 1.
Sir, you sound kind of far away.
X over x minus 1 all squared. When the numerator is equal to 0, what's the value of x? Look at the screen and tell me now.
0? What is
0? Yeah. It's going to be 0, right? So that's how we determine what the vertical asymptote is, and that's how we determine the horizontal asymptote, right? We're going to be required to plot graphs. We're going to be required to plot graphs. So you will need to have an idea what the horizontal asymptote is going to look like, what the vertical asymptote is going to look like, and there are other things that we need to do, such as our critical points will come into effect right here again, right? So pretty much that's it. Don't worry about it. I'm going to send you this question so you can play around, you can look at it, because remember, it's going to be rough on me this semester because it's not that I have an extra day where I can just maybe take a break and send it to you Wednesday morning for class on Thursday, and to give you a good full day to do it. We'll meet again tomorrow. So I'm going to answer, I'm going to send it off tonight. You just look through, then you come to class with your questions. Sir, I looked through, but I don't understand why I did X, Y, Z, and then we can have a conversation surrounding that. Fair enough?
Fair enough, sir.
All the best. Thanks for coming out.
Thanks again, sir.
Yes, sir.
Mm-hmm.